So the idea here is that we're going to take a triple system 3x3. You'll hear me call them triple systems. There's triple systems, double systems. So the assignment that you completed on Thursday or over the weekend, I will post up an answer key for that. Don't let me forget. I'm not going to do it right now, but I'll add it to today's Canvas post. Apparently, I didn't do that yet. Okay, so I'll do it today. So the idea is that we're going to take triple systems today, and we're going to knock them down to double 2x2 systems, and then we're going to knock those down to 1x1 systems, and then you'll grow it back up. So it's basically going to go 3, 2, 1, 2, 3. And that makes no sense right now. But after we finish the first example, it should maybe make a little bit more. So I have 3 examples slated for today, and the best way to learn how to do a triple system is just to get in there and kind of get your hands on it and get it done. So I just would say that if we together as a team are going to survive the next week or so, I really need you not to take lightly, and just shrug off and laugh off things like, oh, I forgot a negative, tee hee hee, because like it's not cute and it's not funny and it's annoying, because in the midst of this problem that will take 100 little math problems to get through, you can't miss any. And I'm not saying that I'm perfect, and I'm not saying that I'm expecting you to be perfect. I'm just asking, please, that you make the most perfect version of yourself for this unit, okay? Because this is not difficult. It becomes difficult when you do knucklehead things like, oh, I forgot to multiply. Well, don't forget to multiply all the way across the equals. Don't forget that -4 + 2 is not 2, stuff like that. We just, again, if we're going to get through this, which we should without too much trouble, we have to be tight on our the little things that, as you know by now, are not little things at all, right? So this is what a 3x3 looks like, and I have 3 of them picked out. I don't know exactly how they're going to flow. Like, I haven't worked through them yet. Every problem has like a flow to it, so I'm not exactly sure what the flow of these is, but I do know at the onset, like at the beginning, they're what I wanted to see. So first one is, and you'll want to start writing right away so that you're not the kid that says, hang on, don't scroll up yet. I was still copying that down, so just kind of try to stay caught up with me. And I cross my Z's. You'll notice that 100% of the time. And the only reason I do that is just so they don't look at all like 2s. So I'll always cross my Z's, just FYI. If you make your Z's nice and rigid with good tight angles, then, as long as they look like Z's, just don't fool yourself. Don't fool me, but more importantly, like, don't fool yourself. Like halfway through a problem, you think it's a 2. So, all right, our second row is going to be 5x minus 2y plus 2z equals -21. I'll give you a second, make sure that you got that one accurately. And then our last one is here. So there's your first look at a triple system. And like I said before, these can get really, really nasty. And not yet, though. Everything is going to feel nice. If things start to feel not nice, like you're getting really weird numbers or you're getting fractions, I'm not saying that going forward that's going to be an indication of wrongness, but for now it's an indication of wrongness. Things are supposed to be nice and fluffy and pleasant for a while. So 3x3, it's 3 equations. It has 3 variables. Our goal is to knock it down to a 2x2, and then we should be able to flex pretty hard on a 2x2. Because again, we did it in Algebra 1, and you did it over the weekend or on Thursday. So you should be pretty well up to par on the 2x2s. So what we want to do first off is we want to label our equations. We're going to come to refer to them as rows, and this is not optional. So we are going to refer to the top one as R1, little lowercase r's, okay? R1, R2, and R3. And the reason why we do this is because this is going to be messy. This first one may not be too messy, but what happens is, honestly, this is partly for you, but full disclosure, it's largely also partly for me. When I have to grade your work, these are hard to grade. And the one saving grace I have is if I look at Erica's paper and some equation magically pops up, I need her to tell me where that equation came from. Okay, so that's going to be an indication of like what I'm going to look for is like a little R1 plus R2. And that's going to tell me, oh, she added the top and the top and the middle equations together. Or if Serenity gives me like an R2 plus R3, then I know I'm in the loop. I don't want to go back and try to decode like what did the kid do to get this new equation. So labeling these R1, R2, R3 is going to be critical to our success. Okay. So having said that, let's dive in. Anything stand out about this? Good for you guys. Good math instincts there. The whys should be very attractive to you. You should be very attracted to them right away. And knowing what you know from Thursday's assignment, you know that to eliminate things, you want them to be opposites of each other. And that Y column, this is the essentially the equivalent of like a 2x2 fluffer puffer, where I give you a system and you just go, wait a second, like one of the variables is just screaming to already get knocked out, right? And so in this case, our target is going to be to murder the Ys. However, unlike a 2x2, to make this work, you have to murder the same variable twice. Yes, sir? If you want them to, right? But I'd have to modify them. Like the negative 3z in the top row, I'd have to turn him into -6. The 2 I'd have to turn into 6, and then the 1 I'd have to turn into 6. So, and that's where we're headed, right? But for now, like I'd be a fool to pick the X's or the Z's because I'd have to do the prep work. And I'm not saying that I'm not up to it, and not saying that you're not up to it, but why not take the freebie? So the freebie in this case is the middle column, the Y's, and so that's what we're going to focus on. So this is as easy as a triple system can get. So when I want a variable to die, I have to look for a combination of that variable that's going to self-eliminate. If it's there, take it. If it's not, like Austin kind of sparked a conversation, then make it there. But it's there. And so what we're going to do is we're going to communicate to someone the process. And this is, I'm telling you, like, don't test the waters here. Don't like see what you can get away with. The first thing you have to do is identify a combination that's going to work. And I'm going to draw this and then I'm going to undraw this. But right now you should be very attracted to what's inside that red box. Agree? Okay, so because the thing we're trying to do is in row 1 and row 2, what we're going to do is we're going to go off to the side. And for the first time ever, we're going to communicate a row. It's called a row combination. We're going to tell someone, hey, I'm about to do R1 plus R2. And all you do is write those down and then draw like a little arrow. Basically, that's your way of saying, okay, hey, hey world, I'm about to show you what happens when I combine rows 1 and 2. Good. So let's get to it. If we take the elements of the top row and the middle row and we combine them one by one, going across or going downwards and then across, how many X's will we get? 1. Very good. So we get 1X. And if you're already lost, let me just, out as a courtesy to you, show you what we did. And again, I'll box it and then unbox it. All we're doing is adding the X's together from row 1 and row 2, the Y's together, the Z's together, and then of course, don't forget you also have to add the numbers together. So it's just a glorified like elimination problem, just bigger, buffed. So if we add row 1 to row 2, the X's right here where I'm moving my pen make 1X. How many Y's will we get right here? What is 2Y and -2Y? Yeah, so don't put anything. The worst thing you could do is put a 0 there. But I appreciate you saying it, but like they're gone, right? And now the Z's, how many do we get? Good. So we have minus Z. And you can put -1, but I don't really feel like that's something we still do. And then add your constants together after the equal sign. What's 15 plus -21? Good. So what we've just done is we've created half of a 2x2 system. Got it? Now, this is important. If you murdered the variable y, you have to do it again. You cannot cancel out a y and then just for shiggles say, oh, I'm going to go kill those z's now. Like, that's not going to do you any good because you're going to wind up with a 2x2 system that's actually not a 2x2. It's going to have too many variables. So you want to not let the variable that you decide you've got it out for, don't let him out of this step alive, right? Yes. And so our next combination that we spot when we're looking for freebies here is, I hope it's obvious to you that's in that red box. Why wouldn't I want to add the top row 1 and the bottom row 3? They don't cancel. They're going to make 4 y's. Like, that doesn't work. 2y and 2y don't cancel. They make more y's. So I'm looking for opposites to make them cancel. So row 2 and row 3 are going to be my next combination. And again, I'm going to communicate that to somebody. So over here off to the side, I'm going to communicate now. Okay, here's what I'm doing. I'm doing row 2 plus row 3. And then after this little arrow, obviously don't put an equal sign in lieu of that arrow, because then you're going to have like R1 plus R2 equals this plus this equals, and you never want to have like a chain of equality. So that's why we use something like an arrow. Okay. So when we add row 2 and row 3, how many x's do we get? We do. Good. And you just have to stay focused on these. So we have 11 x's. Okay. And then add your y's together. How many do you get? None, right? How many z's do you get? Good. And then add your constants together. Good. And I would say at this point that probably looks familiar to you. As I said earlier, the goal is to take a 3x3 and basically knock a layer off of it. And if you take a 3x3 and destroy one of its layers, logically, you're down to a 2x2, which is what we're at, which is why we did Thursdays. We took that one day out of our schedule to do 2x2s, so that what you now see on the board is like, huh, I've done this before. So now we're in the mindset of saying, okay, now that the y's are out of the way, I'm down to a 2-variable, 2-equation system, and you have an option. I think you'd be crazy to pick the x's, quite frankly, but you do have that option. What's the path of least resistance here? Top by 3 is going to get rid of the z's super easy and quick. And I love the z's, not only because the numbers are smaller, but because they're already stacked minus plus opposite like that. So here we are now back to Thursday's lesson. Everything from here on out should feel real smooth and familiar. So I'm going to take this top equation now, and you no longer need to use the row notation once you get down to a 2x2, because the way we show work at this point becomes very easy for everyone to understand. So I'm just going to put some parentheses around the top equation and just show the world, hey, I'm multiplying this equation by 3, just FYI. Good. What does that make him into, the top equation? Just like that. Still good? So as I've done many times before, I'm just going to kind of put a little strike through on this equation, not to destroy it and wipe it out of existence, because it might still serve a purpose later, but I'm striking through it just to show myself that I don't want to accidentally look at the wrong numbers. So I'm going to use the white equation and then the new red one below it, and now I'm going to do a linear combination on those, right? Add them together. So when we add these two equations right here together, how many x's do we get? I agree. How many z's do we get? Of course, none. That's the whole point, right? They cancel. The 3 and the minus 3 went bye-bye. And then what is negative 24 plus negative 18? Good. And like I have said before, like, we're in the fluff zone right now. We're in the kind of honeymoon phase of this, where for a day or two, we're going to get nice answers. Maybe 3 days. I don't even know. But so if you were to get like, a negative 42, and then you're trying to divide it by like 8, you'd go, that's going to be a fraction. I must have done something. So that'd be a good chance for you to go back and kind of retrace your steps. What is negative 42 divided by 14? It is exactly negative 3. So let me sort of try to diagram this for you here. So far, I assume you're not lost. What we have right now, and I alluded to this earlier, and I hope this makes sense now. We scaffolded our way down, and I'm going to erase all of this vandalism here in a second, but we started with a 3x3. We created a 2x2, and we have now worked it down to a 1x1. So that's going to be the structural flow of these problems as you go from 3x3 to 2x2 to 1x1. And now to finish the problem, you're going to actually do that exact process in dead reverse. So instead of going from 3 to 2 to 1, you're now going to go from 1, plug back into 2, plug back into 3. So at this point in time, I know my answer. I know this much of it. My answer, by the way, is going to be an ordered triple. So get used to this. And again, I'm not going to show, I said I'd show you a YouTube video. Today's not the right day. So, but I'm going to show you, like, we're now finding points in three-dimensional space. There's now an x-axis and a y-axis and a z-axis for 3 dimensions. So what we know so far is that the point has an x-coordinate of -3. So I can put that right here. Now, this is a really important question. And this is not optional. This isn't like a discussion or a debate. Which one do we have to find next? You have to find z. And it's not because of some alphabetical thing. It's because I don't have enough information to find y, because y is up here in the 3 by 3. And to solve a triple equation with 3 variables, you better know 2 of them. But I only know 1, so I can only plug back into these equations that contain only 2. So we have a few options. We have original top, the one that I did the strike through. We have original bottom, and then we have new red bottom. Which one do we like the best? Yeah, the OG top one, right? That's kind of attractive to us. So what this equation says, if I pluck him out of here, is he is x minus z equals -6. See it? You could have done that in the one right below it, and you could have done it in the red one right below that. Any place where there's the one you know and another one you need, it's fine. They're all going to work the same. And assuming all my attempts at teaching you basic algebra have gone well so far in our first year and a half together, then you know how to manipulate this equation. For me, the quickest course of action to solve would be to take the -z and move it over to make it +z, and then to take the -6 then in turn and switch it back over. It's just basic mental math. So you should get z equals 3. We agree? So I can now go to my puzzle down here, my solution, and say, okay, I already knew x. I plugged it in, and I just figured out that z equals 3. And now this is the step, I call it storming the castle. This is where the castle is like this big, intimidating 3 by 3 system up here. But again, you're not ready to fight this battle until you have 2 soldiers. And we now have 2. We have X and Z. They're going to join forces, maybe lock arms and storm the castle and say, now together we can pull out our buddy Y. And it's, again, preferential thing. You know, Blair might like the top equation, and Erica might like the second equation, and then Haley might say, you're both crazy. I like the third equation. It's not going to matter if everything has gone right to this point and you don't make any mistakes. Which one are we more attracted to? I would think that you're probably the most attracted to R3. Not to tell you your business, but that one is nicer just because all things being equal, lots of positives and lots of small numbers. So I'm going to take out that bottom equation now, and I'm going to rewrite it. And when I rewrite it, I'm going to be replacing the X and the Z, because I know what they are, with numbers. So it's going to say 6 times X, which is 6 times -3, which is -18. And I do need to keep it saying plus 2y, because I don't know why. And then it's going to say plus Z. What am I going to put for that? Plus 3 equals -3. I say this again. If like that green equation is something you can't handle, then I have failed you as your algebra teacher to this point. Like, you're going to combine the -18 and the 3. So these two that I'm circling in red, you would put together. What do they make? They make -15. And then you have to kick that -15 to the other side. And you wind up with 2y equals 12. Divide both sides by 2. And there is your first answer. Can someone shut the door, please? Thanks. So far, so good. It's a process, and you see it's meticulous. So easy to go off the rails at any given time to overlook one little thing, and then it's all gone to the pooper. And the trouble is, if we make a lot of little mistakes, then there winds up being a queue of 7 kids waiting for Mr. Ahern to look and see where they made their mistake, and it gets out of hand in a hurry. So just be as tight as you can. And while you're waiting for me, go back through your own steps. Check every multiplication, every distribution, every changing of signs, every combination. Check it all. Okay. Larry, you doing okay? You may throw some ice water on you? Okay. That sounds good, doesn't it? Example 2. So this one's going to get just maybe a tiny bit more difficult. Tiny bit. 5x plus y minus 2z equals 8. Negative 3x minus 4y plus 3z equals negative 11. And 3x minus 6y. That's the worst y of all time. Let me fix that. There you go. Got it right like a big kid. Plus 4z equals 3. So I'm not going to ask you rhetorical or condescending questions. You obviously see that this time there is no one fully self-eliminating variable, right? You have options. But again, you're pretty smart. You've proven this to me all year. Of the 3, who's probably got your eye? X. The X's. Why? Because it has one pair ready to roll. Good. So this is a really critical juncture in this lesson. I'm going to teach this the way, this is a little different than the way I used to show it, but I think it's cleaner. It's going to feel like maybe a little bit more upfront, but then it's going to come out so nice. So basically, here it is. The moral of the story is, let's make this into a fluffer puffer like the first one was. So while we are in love with the fact that 2 of the X's are ready to rock and roll, we're essentially going to wind up combining or modifying all 3 rows just to make all 3 numbers the same. There's another method for this, but my history with this has shown me that it can get really messy. Let's try this. So when you look down at the row of X's, what could they all be? Let's make them all 15s. And just be aware, mindful of the fact as you do this, that you need at least one of them to be an offsetter. So like if they were all positives, you need to just flip one. Just one is all you need. That one to sort of infect the others, right? To offset the others. But in this case, we already have our negative on the 3. So the target here, really, the objective, if you will, is just to look down at this row and say, I want all you suckers to be 15s. So we're going to reconstruct the whole system from the ground up, and this is worth it. So I'm going to take this top row. What am I going to multiply by? 33. Second row, what do I multiply by? 5. And I want you to notice that against my own instructions, I am not right now labeling the rows. In case you caught that, I haven't labeled them R1, R2, R3, because I'm not yet to the point of the problem where I'm doing any combinations with rows. So we're going to wait until we do this prep step, and then we're going to go R1, R2, R3. Yes, ma'am.
So when you said you don't want stuff to be negative.
Yeah, we got to have at least one that's different than the other 2. Does that make sense? I mean, you could turn another one negative. So you basically want 2 of one flavor and 1 of the other. Like that's inevitable that you're going to have that, right? And what do we multiply the bottom row by? 5. So here we go. And I'm going to try to leave enough room here so I can show you now. We're doing this together. So as a team, what is our new R1 going to be? 15x plus 3y minus 6z equals, beautiful. Okay, and that will now get the name of R1. Okay, as soon as the system is like ready, you're committed to start doing R1, R2 operations, then that's when you give them a label. Don't label them before this because they're not going to get used in their current state. Wait to label it until you're like, all right, just go time. All right, help me out with that second row. What's he going to be? Plus 15z equals. Good job. And that, of course, will earn the name R2. And then finally, we're on to row 3. Let's manipulate him. What does he become? And then, of course, we label this one as R3. You would agree now that we're right back to where we were before. So let's see if we can plow through this relatively quickly. I think all the work from here shouldn't take us more than 3 or 4 or 5 minutes tops. So we're at the beginning now of what would have been the last problem where we're ready to go in and do row operations. So what's our first row operation? R1 plus, that works for me. So again, I find a pair of opposite x's in row 1 and row 2. So my first row operation is going to be this, R1 plus R2, draw a little arrow, and we're committed. Here we go. What's it going to be? Remember, and this is where it happens all the time, is people look at these, and it's really easy to do. So remember, those are dead to us now, right? Sort of temporarily, like they're not out of the game, but don't look at them. Look at your new the hard-earned new guys. What's R1 plus R2 going to be? Negative 17y plus 9z equals negative 31. Good job. Okay, where are we going to find our next pair off that murders some x's? Good, so we need to write that down. R2 plus R3. I don't mean to make idle threats here because it's not idle, but I'm telling you, if you do not specify R1, R2, R3 stuff, I'm not going to grade it. I won't, I'll hand it back to you. Put a 0 on it or whatever. Okay. So we're going in R2 plus R3. What do we get? Good job. Say it again. That's not going to work for me. Yeah, and that's how quick it can get away from you. Like if you say 40 there, it's over. You're going to spend 5 minutes on the rest of this problem and then 6 minutes waiting for me to tell you what you did wrong when it was just adding. So it happens in a hurry. So for the first time ever, you're faced with a 2x2 system that should make you massively uncomfortable, right? No, that's going to make 105 and 135. It's not going to work for me. Listen, if you walk up to most people and anyone who knows anything about math and you put a 5 and an 8 in front of them and say, hey, what can you turn those both into? Like someone who's not been in school for 20 years would say, well, 40, duh, what do you think I'm an idiot? But if you walk up to even a math expert and say, what can you turn a 17 and a 50 both into? They're going to look at you like you got two heads, right? Same with 9 and 35. That's not light work, is it? So when you're faced, not if, but when you create a 2x2 system that has massive and uncomfortable numbers like this, a good trick to use so you don't hurt your poor brain is just multiply them by each other. Okay, it's sort of a ghetto-y trick, and sometimes it's not the most efficient, but we're probably going to use calculators anyways, right? So why be scared of these big girthy numbers when the calculator is going to do all the heavy lifting anyways? So do you want to kill the x's, or excuse me, the y's or the z's? Okay. Not the choice I was anticipating, but I'm going to go with it because I heard it. So here it is. I'm going to take the top row times 50. And I'm going to take the bottom row times, and don't say 17. Good job. Negative 17. You got to force the whole 1b positive, 1b negative issue. Right? And we're well outside our comfort zone. Like even I, who sits up here and does this all the time, like I'm not comfortable with doing all of this in my head. I think the first one's negative 850, but you're going to have to keep tabs on me here. So like if I multiply the top one by 50, is it negative 850y? You might think, well, I've never done this before. It's okay. It's all going to come out in the wash. And then the second one, we can handle that in our brains. That's just plus 450 z. And then again, in the back, we got big stuff here, but that's just 1,500 plus another 50. So that's negative 1,550. Feel free to use your calculators liberally when you're navigating through this stuff. Just don't rinky dink forget negatives and God dang, man, don't do that. All right, on to the bottom row we go. What is negative 17 times negative 50? Yeah, I mean, if that doesn't come out the same, then you just wasted your time, right? And then 17 times 35, that's the one that's a little tough for me. What's that going to be? So negative 595 Z. And then, of course, 17 times 40 is negatives positive 680. Good. So you could say like, wow, that was hard, but I would disagree. Like your calculator again is going to do most of that for you. It's kind of a big buffed up like steroid system, eh? It's okay. So when we add these together now, I think it's obvious that the X's are going to, or the Y's are going to cancel. How many Z's do we get? It's definitely negative what? Negative 145. And what's negative 1550 plus 680? Again, definitely negative. I'll get that part out of the way. You do that in your head? I don't think so. I think you forgot to borrow. 970 is going to put us up at 1650. Negative 870, right? Yeah, you forgot to borrow there, Blair. Oh, sorry, Claire. I called you Claire. I'm gonna call you Claire for the whole rest of the day. And then you divide 870 by 145, and what do you get? 6. Good. So like I kind of said, for now, there's some peace of mind in knowing that you've seen this in this class before. Like if I get a fraction, I did something wrong. You might remember some stuff like that. And we're going to still be on that road where if it comes out to 6, that's usually a pretty good sign. Common mistake I see is someone gets so excited about the ending and they type it in on their calculator and they get the whole number and they go, this is it. I made it to the end. And that's usually where people screw up the signs, is right there. Because you get ahead of yourself and feel good about that whole number. So that is definitely supposed to be a positive 6. So when we construct our final answer, it has to look like this. We agree? XYZ triple. It's called an ordered triple. Who do we have to find next? You have to find Y. Dork. I almost did the same thing. So what does that say about us? So yes, we have to find the Y. Because if I can only go someplace where there's 2 variables if I only know 1. And again, if you select one of these, I'm going to probably have you sent to the office for a drug screening. Like you're going to need to check this kid, search the locker. There's something going on here. So don't pick the big steroided up. We needed those for a purpose, but no longer. So which one do you like better, top or bottom of the 2x2? Top. Okay, so top it is. So we're going to take this top equation. I'm going to put like a green box around it, and we're going to pull it out and change what we know about it as we go. So it's going to say negative 17y plus what? 54. 54 equals negative 31. Basic algebra here, subtract 54. What do you get? Divide both sides by negative 17. What's y? And we now can complete the second piece of the puzzle. And now it's time to storm the castle because I've got 2 combatants now. You have to have that level. Like you got to be level 2 before you can get in there. We're level 2 now because we know 2 of the 3 guys. So we tote around now a 5 and a 6 for Y and Z, and we look at our very original problem. These ones that I lightly crossed out in yellow earlier are probably where you'll go, right? Again, you're not going to be judged as harshly if you use the ones over on the right. Right? No drug screening for that. But still, why go somewhere where the numbers are bigger? So I imagine a lot of you would be attracted probably to the top row. And so if I take the top row, put a purple box around it, and I can now replace Y and Z with who they are. So what's that equation going to say if I replace Y and Z? Yeah. And you should be nearing a point in your education where you can do all of what I'm asking you to do in your head. What's 5 minus 12? -7, which means you have to add 7 across. What's 8 plus 7? What's 15 divided by 5? So you now know that x equals 3, and you can complete the puzzle. Done. That means that the 3 flat surfaces defined by the original 3 variable equations are 3 planes floating in space that cross at a very singular point, 3, 5, 6. And that'll make more sense once I show you a YouTube video that, with cool, like high tech animations and stuff that make it all possible. So far, so easy. Okay, let's start one more. And yeah, you asked if it was a long lecture today, Blair. I didn't want to lie to you. This is always a long one. And then there'll be a lot of work time at the tail end of this, like obviously a little bit today, but then a nice big chunk tomorrow. So. I used to teach this differently, and I feel like this is the right way. So I'm actually not even going to show you the other way. Even if you were to ask me and you wanted to come in on some like other time, I would show you, but you'll agree that this is much tidier. So you kind of knew this is where we were headed, but what's the upshot here? Like when you look at this, what do you take away? Literally nothing. There are no 2 pairs of common variable terms that will auto cancel. And you can't even make a case about those 2 z's. Why? They're both negatives. It's not going to do us any good. So again, we have an option here. The last one, I think we were kind of not forced, but kind of led towards those x's because of those opposites. Here, it's just kind of like, just pick, The one I think that would be the roughest would be the x's. Do you guys know what 3, 5, and 4 have to all turn into? That's a toughie. You can see based on this conversation that you're probably not going to pick the x's, but the answer is 60. If you ever see 3, 4, and 5, their least common multiple is 60. So you're probably going to steer away from the x's. If we went down the middle column, bless you, and decided to kill the y's, what's their common? 20. 4, 5, and 1 can all be made into 20. If we go down the z path, what's our common? I feel like z is probably going to be the path of least resistance here. Okay, no wrong. If you want to use the 60s, you go ahead, you masochist, like go ahead. But I'm always going to try to find the one that's going to make me the least stressed. So I'm going to go Z's. So I think about that column now and I say, you guys all need to become 10s. And do I need to do any sign changing? I do not, because there's 2 that are the same and 1 that's different. And again, that 1 that's different is the one that is always part of making something cancel. So here we go. What are we going to multiply the top row by? Yes. Second row. Third row. Good for you. Yeah. If you can just make it through here without doing anything goober-headed, and then, which is a lot to ask, I know, but we could do this. What's the new top row? Help me out. Negative 15x plus 20y minus 10z equals 50. Good. Okay, second row. Third row. And what's the only thing from here that's stopping me from proceeding? Forgot to label. Good job, you guys. You're in tune. Good job. Good class. So this has got to be labeled R1. This is R2, and this is now R3. And I tell you again, like, and you understand why I did it this way. Again, I'm going to kind of put a strike through these, not to destroy them and make them not readable, but to do enough to remind myself to stay away for a little while. Don't get confused. So it's time to begin row operations. So which two are, and it's just, by the way, these, had I screened these examples and actually worked through them, I might have picked a different one. I don't want you to get the impression that it's always going to be R1, R2, and R2, R3. It just is the way the cards have fallen in this case. So don't think that that's some kind of like, ooh, it's always top, middle, bottom. It is. Blind luck. So here we go. First combo is R1 plus R2. And what do we get? Negative 5x plus 30y equals 0. Good job there, Bryce. And our second row combo is? What's that going to be? Nice job. Good basics. No mistakes there. I appreciate that. And this one is much more warm and fuzzy than that last one with the 50 and the 17 and all that stuff. So like, I think this one's probably screaming at you. The X's are like, for God's sake, pick me, because I can just modify the top row. So like in this top row, what do we wish this negative 5 was? We wish it was a positive 10. And, you know, with a quick flick of the pencil, we can make that happen. So what are we going to multiply this top row by? Negative 2. And with double systems like this, if I'm only going to modify one of the rows, I like to just write it above or below, usually below. If I'm going to kill the top, put it below. If I'm going to kill the bottom, put it above. Kind of like the two I'm going to combine, I want to be kind of touching butts there. So here we go. What's it going to say? Minus 60y equals 0. And these two rows now, right above this purple line, are the two now that I'm going to combine to get us down finally to the promised land, the 1 by 1. So when I add them together, what do I get? There it is. So finally, the first piece of the puzzle falls into place. And I'm telling you this again, not because I like to hear myself talk. You can believe me or you cannot believe me. But as someone who's about to have to do a bunch of these, you should want this. This is where a lot of mistakes happen. There's something about it, like you take your foot off the gas at that point and you just know, you're like, yes, 55 divided by 55, it equals 1. You put 1, and then you and I together spend 7 precious minutes of our lives trying to figure out where it went wrong, right? So just because you feel like you're at the end, don't do anything stupid. Why is negative 1? So now we're going to scaffold our way back up. The answer at this point in time, I can definitively say, has a negative 1 in the center. And who do we have to find next? Absolutely. And top is probably pretty physically attractive to you, so I'm going to take a green box and put it around the top. Got nothing against the bottom, as the top seems nicer to me. So what would it say if I like rewrite it? So just minus 30. And then again, by now, this should be light work. Add 30, divide by negative 5. What's x? So you can stick a negative 6 down and complete the second piece of the puzzle. And now we're ready to storm the castle. We're level 2. We know x, we know y. Together, they lock elbows, storm through the gate, and say, we're going to go rescue our homie, Mr. Z. So at this point, with negative 6 and negative 1 in tow, or together, we probably go back to the original one that I have the little yellow cross through. So negative 6 and negative 1 are my two that I know. And so here we go. Top, middle, or bottom? I'd heard bottom first. So, oh my God, you crackhead. Oh, I just said that on video. Dang it. I'll say it again, crackhead.
You cancels it out.
Here, I'll add on to it. What they give you for breakfast? Crack flakes?
Say negative practice. So you cancel it out.
Yeah, -2 crackhead, canceled out. So if we do the bottom equation, I don't know why you picked the bottom. It has negatives just shooting all over the place, but whatever, you do you. So here it goes. Too late. We're already committed. I'm gonna do the first one I hear. I heard bottom first. So -4x would be 24. Minus y would be actually minus -1, which is +1, and then -2z. Ellie must really like negatives. Equals 21. Again, do the math. 24 plus 1. Subtract 25. Divide by -2. Done. As you work through the rest of today, you don't have a lot of time, but we can get started today. As you work through, don't stop listening. You're going to encounter things that did not come up in the lesson. Weird things where like maybe you try to kill one variable and you're like, what the heck, I just killed 2. We'll have those discussions as they arise. Okay, good. All right, why don't you pop open the old Delta and let's just at least get the first problem. Let's get it started. We only got about 6 minutes, but we could get one going.
Actually, that might be-